Today we discuss about what is the relationship between this free energy change and EMF of a cell. Very important thing. Actually, this is not the theory is not required. Only you have to remember this formula, and basing upon this formula, he will put the problem. That is very important. So, he may put short questions from this. So, I am already writing these things in the blackboard. Look at this. So, what is the relationship between these free energy? As we have already discussed in the first year, that what is free energy? What is free energy? So, free energy, what we can say that what is free energy? The amount of energy available from a system for doing any useful work. That is called free energy. How much amount of energy is available from a system? As we have already discussed vividly in thermodynamics, what is a system? A part of the universe which is selected for any thermodynamic study is called system. Already I have given you the explanation vividly in thermodynamics first year. So what is system? A part of the universe which is selected for any thermodynamic study is called system. And let this classroom will be a system. Outside this classroom, that is surrounding. So system plus surrounding, that is universe, as we have known this clearly. So what is a system? A part of the universe which is selected for any thermodynamic study is called system. Let our body is a system. Human body is a system, and human body is a system. So a part we are using, suppose we are consuming food and gaining energy, but a part of energy we are utilizing for walking or for reading or any type of useful work, whatever we are doing in our day-to-day life. So total energy is internal energy of your body system. Let total energy is internal energy of your body system. A part of energy is utilized to do useful work, that is called free energy. So suppose if total energy is internal energy, like internal energy is nothing but the sum total of every possible kinds of energy possessed by a body system. So a part of energy is available from a system for doing any useful work. A part of energy is useful. A part of energy is useful for doing any useful work. That is called what? Internal energy. So what is internal energy? The sum total of every possible kinds of energy possessed by a system is called internal energy. A part of energy is utilized for doing any useful work, that is called free energy. So total energy is internal energy. A part of energy utilized from this, that is free energy, that we can denote G, and change in free energy, that is del G. Since we know that free energy is an exact differential, free energy is a state function, we never determine the absolute or exact value of any state function, rather we only calculate the change in values. Clear? Rather we only calculate the change in values. Is that clear? So first thing, let me assume. So what is free energy? The amount of energy available from a system for doing any useful work, that is free energy. The amount of energy available from a system for doing any useful work, that is called free energy. A part of energy. Suppose we are consuming food and gaining energy. We are getting energy from water and also from air. Different forms of energy. We have different forms of energy our body gains from outside also. So total energy is internal energy. जेतिकी सपोज बॉडी रे तुमे खाद्य खाउछो, निश्वास नउछो, पानी पिउछो, डूइंग एक्सरसाइज करूछो, डिफरेंट थिंग्स यू आर डूइंग. जो टोटल एनर्जी ऑफ योर बॉडी सिस्टम, दैट इज इंटरनल एनर्जी. किछि एनर्जी तुमे सपोज यूजफुल वर्क काम पय खर्च करूछो. सपोज यू आर रीडिंग, यू आर रनिंग, यू आर वर्किंग, you are spending some amount of energy for any useful work, that is called free energy. The amount of energy available from a system for doing any useful work, that is called free energy. The amount of energy available from a system for doing any useful work, that is called free energy. Clear? So this free energy change is defined as the maximum energy available from a system for doing any useful work, and that is we are denoting useful work W max. W max, that is 1. So this free energy change is defined as the maximum energy available from a system for doing useful work. that is free energy. And what is free energy chain? Free energy, as we know that free energy is a state function. Free energy is a G is free energy. G is free energy. G is free energy, which is a state function, and we never determine the absolute or exact value of free energy. Rather, we can only calculate the change in free energy, that is G2 minus G1, which is del G. So free energy in the final state, free energy in the initial state. Free energy in the final state, free energy in the initial state. So G2 minus G1, that is del G. G2 minus G1 is del G, that is free energy change. That is free energy change. Here. So give free energy change del G is defined as the maximum energy available from a system for doing useful work, W max. Next, so if the potential of the two electrons in an electrochemical cell differs by E cell, then the maximum work done will be given as W max equal to MF E cell. So if the potential of two electrons in electrochemical cell, there are two electrons. One is suppose zinc electron, another is copper electron. We are placing two electrons in electrochemical cell. हमें electrochemical cell ले कितने electron होते हैं? दो electron होते हैं, दो electron पर दो potential. So two electrons have two different potential. Zinc electron का potential, copper electron another potential. So point अगर if the potential of the two electrons in an electrochemical cell differs by E cell. E cell क्यों निकालो? Simple EMF of this cell we are calculating. The algebraic difference between the electron potential of two cells is called EMF of this cell. What is E cell? EMF of this cell. How we can calculate the EMF of this cell? Simple. The algebraic potential difference between the two electrons gives the EMF of this cell. तारो गोटे potential गोटे value देबो, another out गोटे electron potential, suppose गोटे electron potential अछि x, out रे अछि y. So EMF टा केन दिगल x minus the algebraic difference between eta first electron potential, eta second electron potential. So how can we calculate the EMF? EMF equal to the algebraic difference between the electron potential of two half cells is called EMF. The algebraic difference between the electron potentials of two half cells is called EMF. So similarly, जदि दुईटा इलेक्ट्रोड अछि, गोटे इलेक्ट्रोड गोटे पोटेंशियल, आउट इलेक्ट्रोड आउट पोटेंशियल. See the दुईटा potential difference that will give the EMF of this cell. That difference will give the EMF of this cell. So first electron potential suppose x, second electron potential suppose y. Then EMF of the cell x minus y. So already I have given the formula. If the two electrons potential are given in reduction term, so EMF E0 will be calculated. Reduction potential of cathode minus reduction potential of anode. If the two potentials are given in oxidation term, it is given E0 cell equal to oxidation potential of anode minus oxidation potential of cathode. That is the formula already we have discussed previously. So simply I am giving, if the two electrons are given, first electron, second electron, first electron potential suppose x, second electron potential y, then EMF of the cell equal to x minus y. Simple. The algebraic difference between the electron potential of two half cells is called EMF of the cell. So what is EMF? The algebraic difference between the electron potentials of two half cells is called EMF of the cell. The algebraic difference between the electron potentials of two half cells is called EMF of the cell. Clear? So if the potential of the two electrons in an electrochemical cell differs by E cell, then the maximum work done will be given by W max equal to NF E cell. E cell EMF of the cell, F is 1 Farad, F equal to where? F equal to 1 Farad, 1 Farad equal to 96500 coulomb. Then N, what is N? Number of electron transferred from anode to cathode. How much electron transferred? How much? Suppose anode re kon oxidation, at anode oxidation, at cathode always reduction. Anode loss of electron, reduction cathode re kon gain of electron. Anode oxidation, loss of electron, cathode reduction, gain of electron. So what is N? N is number of electron transferred from anode to cathode. How much electron transferred from anode to cathode? That is N. Faraday F equal to 1 Faraday 96500 coulomb. F equal to 1 Faraday 96500 coulomb. So W max equal to NF E cell. W max equal to NF E cell. So N is the number of electron transferred from anode to cathode. F is 1 Faraday. 1 Faraday equal to 96500 coulomb. E cell EMF of the cell. E cell equal to EMF of the cell. Next, when a galvanic cell operates, an electrical energy flows through the external circuit. Work is done by the system. Look at when galvanic cell operate, as already I have discussed the operation of galvanic cell. Left side is zinc electrode, zinc half cell. Right side is copper electrode, copper half cell. Then the two electrodes are connected to the two ends of the galvanometer by the insulated copper wire. The two left side कौन थिला zinc electrode टा बुढ़ाई थिला zinc 0.1 m zinc sulfate solution में. copper electrode टा बुढ़ाई थिला copper electrode is immersed in 0.1 m copper sulfate solution. zinc electrode टा बुढ़ाई थिला zinc sulfate solution में 0.1 m zinc sulfate solution. copper electrode टा बुढ़ाई थिला 0.1 m copper sulfate solution में. दुईटा इलेक्ट्रोड को इंसुलेटेड कपर वायर देके गैल्वानोमीटर रो दुई साइड को कनेक्ट कराई था. तापरे कोन होतला इलेक्ट्रॉन लॉस होतला को एनोड रे जिंक हाफ सेल इलेक्ट्रॉन लॉस होतला से इलेक्ट्रॉन टा फ्लो करतला कोड एनोड टू कैथोड एंड करंट टा फ्लो करतला कैथोड टू एनोड. एटाला मेकानिज्म ऑफ कोडा गैल्वानिक सेल. मेकानिज्म ऑफ गैल्वानिक सेल और वोल्टाइक सेल और इलेक्ट्रोकेमिकल सेल. एटी सेटा कहला माने गैल्वानिक सेल ऑपरेट्स. Galvanic cell is the operate kurchi that produce, and what is the objective of galvanic cell? We are using galvanic cell for the production of electrical energy. Galvanic cell definition कौन थिला? Galvanic cell definition थिला जे it is a cell or device which is used to convert the redox reaction. It is a cell or device which is used to convert the chemical energy produced in a redox reaction into electrical energy. And galvanic cell produce कौन करतला chemical energy को convert करतला electrical energy. galvanic cell definition कौन दिला? galvanic cell produce or convert chemical energy to electrical energy. galvanic cell convert करतला chemical energy को कोथरे electrical energy रे. So same thing when a galvanic cell operates and electrical energy flows through the external circuit. galvanic cell जो operate कला electrical energy flow कला electricity flow कला को cathode to anode. electron flow कला को anode to electron flows in the galvanic cell. electron flows from anode to cathode. current flows from cathode to anode. electron flows from anode to cathode. current flows from cathode to anode. Clear? So when a galvanic cell operates and electrical energy flows through the external circuit, work is done by the system negative side. So maximum work W max equal to minus del G NF E cell. Minus why this is negative sign? The negative signs decrease in free energy. Actually net decrease in free energy is completely converted to net electrical work done. It is a net electrical work done. This is net electrical work done. It is a net decrease in free net decrease in free energy equal to net electrical work done. Net electrical work done is NF E cell. Net electrical work done is NF E cell. Net decrease in free energy minus del G. Minus del G equal to NF E cell. Clear? So this is the formula. So maximum work done equal to this much. Maximum work done equal to minus del G, which is equal to NF E cell. This is the formula. This formula is only needed to solve the problem. Look at it is a non-standard state, that is at any temperature and any concentration. But at standard condition, this formula can be represented. It is a non-standard condition. Standard condition में formula क्या लिखियो? At standard condition, W max equal to minus del G dot W max equal to minus del G naught, which is equal to NF E0 cell. At standard condition, W max equal to minus del G naught, which is equal to NF E0 cell, and that is at 25 degrees centigrade or 298 Kelvin. That is standard condition. At standard condition, you can apply this formula. There are two formulas. First is this, second is this. 8 data formula one at least. Jodi se pachala what is the relationship between free energy and EMF of a cell? You will write simple minus del G equal to NF cell, or this is the formula. Or he will put maximum work done, that is maximum work W max equal to minus del G. So W max equal to minus del G equal to NF cell. What is minus del G? Net decrease in free energy. What is NF cell? Net electrical work done. Net electrical work done. So net decrease in free energy is completely converted into net electrical work done. Net decrease in free energy, net decrease in free energy is completely converted into net electrical work done. So maximum work W max equal to minus del G, which is equal to NF cell. NF cell stands for net electrical work done. NF cell stands for net electrical work done. Minus del G stands for net decrease in free energy. So W max equal to del G, which is equal to minus NF cell. At standard condition, at standard condition 25 degree centigrade 298 Kelvin, W max equal to minus del G naught, which is equal to standard. It is a non-standard condition. It is a standard condition. Standard condition में formula है W max equal to minus del G naught, which is it is only standard condition 0 possible. Del G naught or del G 0. It is called del G naught or del G 0. Del G naught equal to NF E naught cell. Del minus del G naught equal to NF E naught cell. Minus del G naught equal to NF E naught cell. Clear? So these two formulas are very important, and it is on standard condition. It is standard condition. At standard condition. Or another formula, del G naught equal to minus RT log Kc. Kc is the equilibrium constant. Kc stands for where? Kc stands for equilibrium constant. And another formula, del G naught equal to minus RT log Kc. Del G naught equal to, in log is converted to log, you have to multiply 2.303. So these are the two formulas. Del G naught equal to minus RT. It is first is in terms of log, second is in terms of log. Del G naught equal to minus RT log Kc. Del G naught equal to minus 2.303 RT log Kc. There are two formulas. You can apply this formula. First is del G naught equal to minus RT log Kc. Del G naught equal to minus RT log Kc. Del G naught equal to minus 2.303 RT log Kc. Clear? So these are the formula which are required in order to solve the problem. Another formula I am giving next and right. So you should remember what is the relationship between free energy change and EMF of the cell. This is the relation. Minus del G equal to NF. So if you will put short question, what is the relationship between heat free energy change and EMF of a cell? You can write this. Minus del G naught equal to NF cell. This is the only formula. What is the relationship? Question: what is the relationship between Gibbs free energy change and EMF of a cell? Minus the relationship is minus del G equal to NF cell or minus del G naught equal to NF E0 cell. Take a look. Minus del G equal to NF cell or minus del G naught equal to NF E naught cell. This is the formula. Correct. So if you have one more question. What is the relationship between Gibbs free energy change in EMF of a cell? Minus del G equal to NF cell or minus del G naught equal to NF E naught cell. This is the relation. Or here will another question put. What is the maximum work done that can operate in a cell? That maximum work done equal to W max equal to minus del G. Minus del G equal to NF cell. So you can apply this formula, calculate the maximum work done. Applying this formula, you can calculate. We will solve problems basing upon this. So maximum work done that can be calculated by applying this formula, W max equal to minus del G, which is equal to NF cell. Or at standard condition, W max equal to minus del G naught, which is equal to NF E naught cell. NF E naught cell. or del G not equal to minus RT ln Kc, del G not equal to minus 2.303 RT ln Kc. So ln is converted to log, you have to multiply 2.303. Ln is converted to log, you have to multiply 2.303. Clear? So this is the relationship. एटी जदि से डिस्क्रिप्शन करते पहले फर्स्ट डेफिनेशन लिख दो कोड गिव्स फ्री एनर्जी चाहिए. नेक्स्ट if the potential of the two electrodes in an electrochemical cell differs by E cell, then maximum work will be given W is equal to NF E cell. NF E cell. So when a galvanic cell operates, an electrical energy flows through the external circuit. Work is done by the system. When work is done by the system, that is negative. When work is work done on the system, work done by the system on the surrounding, that is negative. Work done on the system by the surrounding, that is positive. Reverse. Work done on the system, work done by the system. Work done by the system on the surrounding, that is negative. Work done, it is system. Work done by the system on the surrounding, it is surrounding. Work done by the system on the surrounding, that is negative. Work done on the system by the surrounding, that is positive. देखो ये टर्म मन रखो. Work done by the system on the surrounding, negative. Work done on the system by the surrounding, that is positive. That is what? Positive. Clear? So you can apply that thing. So you can apply that thing. When a galvanic cell operates, an electrical energy flows through the external circuit. Work is done by the system. Work is done by the system minus negative sign. So maximum work W max equal to minus del G, which is equal to NF E cell. A minus del G, that stands for net decrease in free energy. We can say that net decrease in free energy is completely converted into net electrical work done. Net decrease in free energy minus del G, net electrical work done is NF E cell. NF E cell. So you should remember the formula. First one, equation 1. Equation 2, that this is equation 3. तीनटा formula मन रखिए. Only this. So what is the relationship between V free energy change and EMF of a cell? Minus del G equal to NF E cell or minus del G not equal to NF E zero cell. Clear? Next, when when the reaction is in equilibrium, E cell equal to 0. When the reaction is in equilibrium, E cell equal to 0. And very important thing, जितना reaction का equilibrium condition है तो E cell EMF of the cell equal to 0. E cell equal to 0 means we have to apply it in last equation. We know that last equation E cell equal to inner cell minus 2.303 RT by NF log Kc. In terms of equilibrium constant, that is Kc, or you can take it Q. Q is reaction quotient. In terms of reaction quotient, that is Q. In terms of equilibrium constant, that is log Kc. Next, E cell equal to 0. So 0 equal to inner cell minus 2.303 RT by NF log Kc, or simply we can write 2.303 RT by NF log Kc equal to inert cell, or log Kc equal to NF inert cell divided by 2.303 RT. Log Kc equal to NF inert cell 2.303 RT. This is the formula. It is the 3, it is 4. Look at this, you can apply what is N. N is the number of electrons transferred from anode half cell to cathode half cell. F is 1 farad. E0 cell is standard EMF. R is gas constant. T is temperature. Whatever the terms we have used in Nernst equation, that terms. N is number of electrons, and you can compare it to Nernst equation. What is N? Number of electrons transferred from anode half cell to cathode half cell. What is N? N is number of electrons transferred from anode half cell to cathode half cell. F is 1 farad. Inert cell, standard EMF. R is gas constant. T is temperature, absolute temperature. Next, what is Kc? Kc is equilibrium constant. Kc is equilibrium constant. Clear? Next, this is a non-standard condition, but a standard condition, log Kc equal to N into inert cell this is the condition what we are using in non-standard condition. At 25 degree we can use it at 25 degree centigrade or 298 Kelvin. At 25 degree centigrade 298 Kelvin, log Kc equal to N into inert cell divided by 0.0591. So what is that? N is number of electrons. N is number of electrons transferred from anode half cell to cathode half cell. Inert cell is standard EMF. This is constant. So you can calculate log Kc. Suppose I will solve the problem based upon this. So you remember this formula. This question number. This formula is applied in order to calculate the Kc. Kc is equilibrium constant. What is Kc? Kc is equilibrium Kc is equilibrium constant. Kc is equilibrium constant. In order to calculate the equilibrium constant, we can apply this formula. Clear? In order to calculate the equilibrium constant at non-standard state, you will apply the equation number 4. At standard state, you will apply the equation number 5. You will apply the equation number 5 at standard state. You will apply the equation number 4 at non-standard state. So I will solve the problem. So you remember simply the formula. These two terms. These are not equal. You must remember this line. When the reaction is in equilibrium, E cell equal to 0. That is very important. When the reaction is in equilibrium, EMF of the cell equal to 0. When the reaction is in equilibrium, E cell equal to 0. Clear? Next we will solve the problem basing upon this. Clear? We have to solve the problem basing upon this. Clear? Next I will solve problem basing upon this. How look at this problem. Calculate the maximum possible electric wall question. Calculate the maximum possible work. Calculate the maximum possible work. Calculate the maximum possible electrical work. Calculate the maximum possible electrical work that can be obtained. That can be calculate the maximum possible electrical work that can be obtained from the cell under standard condition at 25 degrees centigrade. Look at it. Calculate the maximum possible electrical work that can be obtained from the cell under standard condition at 25 degrees centigrade to 19 Kelvin. Given that E0 is given that E0 zinc 2 plus by zinc minus 0.76 volt. E0 যেতବେଳେ এই ভলিয়া কোশ্চেন দেইতিব সো ফার্স্ট কোন করিব ম্যাক্সিমাম ওয়ার্ক কাঢ়িবা ফর্মুলা wmax equal to minus del g wmax equal to minus del g naught standard condition देछि wmax equal to minus del g naught which is equal to mf e naught cell. This is the formula. So e naught cell, first we have to calculate the e naught cell. How can we calculate the e naught cell? Look at these two potentials are given. E naught cells, we know that E naught cell equal to reduction potential of cathode minus reduction potential of anode. Reduction potential of cathode minus reduction potential of anode. Reduction potential of cathode minus which is cathode. Look at this is reduction, this is reduction, this is reduction. এটা भी reduction আছে, এটা reduction আছে. দুইটা এর reduction দিলে হায়ার ভ্যালুটা cathode. ওটা হায়ার ভ্যালু, this is higher value. So 0.34 minus of 0.76, 1.10 volt. 1.10 volt. So inner cell equal to reduction potential of cathode minus reduction potential of anode, that is 0.34 minus 0.76, 1.10 volt. Next is we have to calculate the maximum work. Maximum work calculate formula for we know again Wmax equal to minus del G naught which is equal to NF inert cell. W max equal to minus del G naught which is equal to NF inert cell. M এটি কেতে আছে M is 2 how তুমি জানলে কে M টা 2 আছে look at zinc 2 plus changes to zinc how much electron gains 2 copper 2 plus changes to copper how much electron 2 so here N is 2 F is 96500 coulomb E0 is 1.10 এটা ক্যালকুলেশন করো যা আসো সেটা হলো দ্যাট ইজ দি ভ্যালু এটা আসছে অ্যানসার 21232 লেবে আসছে সরি 21230 আসছে এটা জুল কেন এটা ফারাড কুলম আছে এটা হলো ভোল্ট আছে কুলম ইনটু ভোল্ট এটা হলো জুল এটা যদি কিলো জুলে করে দেব এটা সিউ কত ফারাড কত দিয়ে 212.3 This is the answer. So first reduction E0 cell কাট দেব E0 cell কাটার ফর্মুলা অলরেডি ডিসকাস প্রিভিয়াসলি যদি দুইটা জায়গা এটা দুইটা জায়গা রিডাকশন আছে এটি জিঙ্ক 2 to zinc copper 2 to copper তাহলে দুইটা জায়গা রিডাকশন আছে if the two potentials are in reduction then higher value is cathode lower value is anode and formula হলো যদি দুইটা জায়গা রিডাকশন আছে reduction potential of cathode minus reduction potential of anode so এটা হলো 0.34 minus 0.76 1.10 তারপরে W max maximum organ W max equal to minus del G naught and F inert cell 2 into 96500 coulomb into 1.10 it is like 212.3 kilojoule that is the answer clear next our problem করা হচ্ছে next problem calculate the next question calculate the equilibrium constant calculate the equilibrium constant for the reaction for the reaction at 298 Kelvin. Calculate the equilibrium constant for the reaction at 298 Kelvin. 4 Br minus plus O2 4 Br minus O2 4H plus 4Br minus plus O2 4H plus so that gives to 2Br2 2Br2 plus 2H2 2 It is n kate n over 4. And then it is looking at this reaction, how much electrons? That will be 4. So next we will solve this question. Solve this question. We know from the equation that n equal to 4. N equal to how much? 4. E0 is idea of question given that E0 is given that E naught cell is 1.16 volt. So next we know that n equal to 4 and log Kc equal to n into E naught cell divided by 0.591. So log Kc equal to n is 4, E naught is 0.16 divided by 0.591 or log Kc equal to 10.85 or Kc equal to antilog of 10. Already I am from the first year very beginning I am telling you that you should remember the log and antilog. So answer is a 7.04 into 10 to the power something 10. Thank you. Next class we will solve the electrochemical cells.